and welcome to another talk as part of our international seminar series for the TAPAS network. And we're really pleased to have Professor Guangyu Cao with us today. Guangyu has been a professor at the Department of Energy and Process Engineering at the Norwegian University of Science and Technology since 2014. And his research interests very much align with the TAPAS network in the respect he's interested in all things ventilation and indoor air flows and thermal comfort and air quality, etc. But as you can see from his title slide, he's going to talk to us about some measurements that they've been making in Norwegian schools and presumably interviewing staff or pupils to get some perception as well. So that's a really excellent title to see, and I hand over to you, Guangyu.
Yeah. Thank you, Harry, for your nice, very kind introduction, and thanks, Kat, for the kind invitation to present our study regarding indoor air quality or perceived indoor environment in Norwegian schools. So today, my talk will be about the perceived and measured indoor environment in Norwegian schools. So about background, as we all know, that good indoor climates in schools plays crucial role in promoting health, well-being, and effective learning among students. But unfortunately, many schools in Norway face indoor environment problems, primarily due to inadequate maintenance. And maintaining optimal thermal environment is important to create a comfortable atmosphere for both students and teachers. Sufficient ventilation airflow rates should be supplied to ensure adequate indoor air quality to reduce adverse health effects. But still, it is a great challenge to integrate both perceived and measured indoor environment data together to clearly map what's the key factor which affect pupils' health. So today, I would like to introduce three of our earlier studies. The first one was carried out in 2017. That study was to investigate the indoor environment and the effect of indoor environment on students' health symptoms in 3 middle schools in Trondheim. And the second one is our earlier project. It's named School on Hold, or in Norwegian is a Skole på vent project from 2018 to 2020. 3 schools in Trøndelag, it's a local province or region, including primary and secondary schools were involved. And the last study was about machine learning study in 2 schools in Oslo. So in this project, we collaborated and got a lot of support from our partners like NAF, Norwegian Asthma Allergy Forbund, and we collaborated also with local municipalities in Trondheim and in Oslo, and we also collaborated with SINDEF, the research center in Norway. So let's move on. So the first study is the indoor environment and health in 3 middle schools, let's say in Trondheim. So we selected 3 schools that were built in different years. So one school, Hoegen school, was built in 1982, which may present kind of building that may need maintenance already. And then Marga Plassen School, which was built in 2001, which present normal school that may need quite little or minimum maintenance. And then relatively new school, Rosenberg School. By the time of investigation, it was less than 10 years. We use this to represent relatively new schools that needs almost no maintenance investment. So here, this table shows how we carry out the investigation in these 3 schools. So in each school, we selected 5 classrooms. And as we can see that in each school, these classrooms distributed on different floors, and this classroom, they also have different size. Even the number of pupils are quite similar, but the size of school varies from 48 to 127. And measurement schedule. So since school, they have their school schedule when they will take a break and when they will have a lunch. And so the measurement was focused on the school period. So from the first period, 8:30, and till the end of the day, 5th, or even we have this 7th period in late afternoon. Measurement instrument. In this investigation, we use several different types of measurement instruments. So on the photo, we have this Y-cellar CO2 sensor, which this one, I think you can see, this is Y-cellar CO2 sensor, which collects this CO2 concentration. Then we have a TSI dust track and air track, which measure the dust and the PM values. And we have tiny tag, which measure temperature and relative humidity. And we also have this backgassol in the air quality station, which measure CO2 concentration and PM 2.5 and temperature, relative humidity, these parameters. And to avoid damage of instruments, and we put those instruments in a cage, and then, especially this backgassol station, we put this station in a cage and then put it in the classroom. But as for other instruments, as you can see, that as for tiny tag, we just hide this tiny tag under table, and we put air track on top of this shell, and we put backgassol Y-cellar sensor close to the exhaust, which measure the room CO2 level. Then here, these are measurement points. So it shows measurement setup. This figure shows measurement setup in a typical classroom at each school. So the aim was to have similar setup in every room. But due to practical limitations in the room, it was not always possible. So the measurement location for each parameter for the investigated classroom are illustrated here. The red marks shows the location of the air temperature and the relative humidity. And then blue dot, here we have 4 blue measurement locations. So the measurement location for particle counters. And then we have the green one shows the CO2 concentration measurement. In addition to field measurements, we also carry out a questionnaire. This questionnaire is a modified version of Area Blue model developed in Sweden. So this is a method based on the WHO definition of indoor climate. And where the users assess the indoor environment using a scale approach. So this method is widely used. And this questionnaire is based on online questionnaire. So this survey tool was developed and operated by our research partner, NAF, Norwegian Asthma Allergy Forbund, and our collaborator, Kai Gustafsson. We got a lot of support from Kai, and normally our students will contact the school, and then NAF will help us to distribute the questionnaire. And then the classroom or the selected classroom will be a target in the survey. So within a period of time, so answers should be submitted to this NAF database. So after that, our student will get or download results from NAF, and yeah, especially my colleague Kai in NAF will support the data transfer, and then our student will analyze the data. So the questionnaire consists of 38 questions divided into subsections. So I'm sorry, this text is in Norwegian. So normally we deliver Norwegian text to schools because those kids it's easier for them to still to answer in Norwegian. And here measurement results in this Rosenberg school, we can see that the major temperature varies from 21 to 25. There are some peaks, but in fact, the peak 25 occurred during the weekend. So we don't know exactly what happened during the weekend, maybe due to the solar radiation, because the measurement was conducted from the beginning of May 2017 to the mid of May. It lasted 1 week. So maybe the solar radiation play a role over there. And then this in one classroom, classroom 3, and in classroom 4, so the temperature varies from 21.5 to 23.5. And then regarding CO2 in classroom 3, we see that during the normal workday, so the CO2 normally was below 700 ppm. That's some like a strange peak, and we assume maybe there's a student that is curious about our measurement, just blow or exhales air directly to the instrument and then cause a peak. And then in classroom 4, we see that there are peaks during daytime, but still the peak was below 900 ppm. Then measurement result of PM 2.5 in classroom 3. So the PM was lower than 5 microgram per cubic meter. And in classroom 4, we also got some peaks during the daytime, but during very short period, it's even up to 24 microgram per cubic meter. Then let's take a look of the survey results. So in Rosenberg, comparing with this, we have reference school, comparing with a reference school. So Rosenberg has a better perceived indoor environment quality. But when we take a look of the health complaints, so we found that there are some symptoms. There are more complaints in Rosenberg school compared with the reference school. But when we put all survey results together and compare the survey result in 3 schools, so we can find that all schools have more problem with indoor climate than the reference school. And the pupils at Rosenberg school are most satisfied with the indoor climate, maybe due to the modern heating and ventilation and air conditioning system. But in other 2 schools, in Markaplassen and in Hoevegen, so the perceived indoor environment quality and the health complaints are much higher than Rosenberg school. So For example, pupils at Markaplassen report most problem with the indoor climate, and they are dry air, stuffy, or bad air, so varying from room temperature. And at Hoevingen, so the draft is a big problem. Here is a draft in Hoevingen school. So remarks. So the measured indoor climate is not always the same as the perceived indoor climate. So the results from the questionnaire shows that the most common health effects are fatigue, headache, and feeling heavy-headed. And the pupils at Rosenberg School are most satisfied with the indoor climate, which was controlled by advanced HVAC system. Namely balanced ventilation with a rotary heat exchanger with efficiency around 80%. The ventilation rates are controlled with a CO2 and temperature sensor installed in every classroom. And there is three different control strategy for temperature settings, namely comfort setting, which has a set point of 21 Celsius degree, comfort 17 Celsius degree, and economic setting is 16 Celsius degree. Any questions? You just please feel free to stop me if you have any questions. So otherwise, I will continue, and you can still ask in the end of my presentation.
Thank you. That's understood.
Okay, good, Harry. So then I just run forward because I cannot see. You just stop me. I cannot see.
Yeah, if anyone raises their hand, I will stop you. But otherwise,
yeah, please
feel free to carry on.
Yeah, please. Yeah, and okay, and the second study about this intervention study, School on Hold project from 2018 to 2020. So there's a background of this study. So every fourth year, Trondheim municipality will consider the state of all schools, all public schools, and they are divided. Into three categories by color: red color, yellow color, and green. So red color means that the school needs massive investment, and yellow needs some investment, and green schools do not need any investment. So in the latest inquiry from 2017, so both Schönland School and this Stabosmo School were marked as red, and Sjöbergen was somehow as yellow. I suppose. And the background and aim of this project has been to survey the indoor environment and indoor environment-related health challenges in schools that have been put on hold when it comes to upgrading or new construction. But sometimes during this on hold period, it takes even several years. And we need to propose some simple measures and routines that can be initiated and easily implemented during this on hold period to improve the indoor environment in these schools. So that's the aim of this project. And we have carried out surveys both before and after implementation of these measures, and to see what has the best effects and which parameter must be in place. So here we have photos of three schools. Two schools were built in the late 70s, and one school built in the late 60s. But in fact, that one, I suppose, it has been renovated. Okay. And the study design. So in October 2018 to January 2019, so the team of project prepared the campaign one including walk-through meetings to each schools and select a classroom to be monitored and based on discussion with the school employees. And then during this campaign, one period from February to March 2019, so we carry out both. We carry out a field measurement and we carry out surveys, and at the same time we interview the school staffs. Then during a period of April to September 2019, so we perform data analysis on measurement results, interview results, and survey results. And at the same time, we identify and implemented some simple measures to improve indoor climate. We propose those measures, and then after that, the school and the municipality, they will try to evaluate which measures will be implemented. And then after the implementation of measures, we carry out the investigation campaign 2. It's from February to March 2020. It also includes field measurement, interviews, and surveys. So then in April to November 2020, we evaluate the effectiveness of the implemented simple measures for improved indoor environment and occupant well-being. And the measurement results in Stabusmo school, and this table shows the measurement results of indoor environment, including CO2, concentration, temperature, and relative humidity. So this table shows results exceeding the recommended limit within school hours at Stabusmo school. So we can see that in one room, the percentage of the CO2 exceeding 1,000 ppm can be up to 27%. So which means that most likely the ventilation effluent may not be sufficient. And in that room, also the temperature, the time of temperature less than 90 Celsius degree is will count 50% of the total school hours. So that means that this room perhaps maybe may cause high draft problems. And then in Sherbergen school, so it shows that these issues were like somehow not that severe. So because as we mentioned, also this Sherbergen has generally better indoor environment than the other two schools. And then after the measurement and also interview with school staff, and we map some simple measures that can be implemented in different schools. And for Stabusmo school, we propose several measures like cut-off setback of set point temperature for ventilation and heating system for night and weekend, and the implementation of external classroom aggregates for the room. It's a below cell. It's the name for the room, and control measurement and troubleshooting part of the ventilation system to detect whether or not fire damper are closed or other fault. And in Switzerland school, and we also propose a measure of cut-off setback of set points temperature for ventilation and heating system for night and weekend, rearrange the placement of pupils' desks to avoid local thermal discomfort. And in Sherbergen school, in fact, it was decided not to make any improvement for Sherbergen due to the measurement results. So it satisfied most of pupils. And then measurement results. So after the implementation of those measures, we carry out a field measurement again. So we can see results both on in 2019 and 2020. So we can see the improvement of room temperature. So the percentage of time outside of recommended boundary values in 2019. So the in room, in one room. So this value was 17. Now in 2020, it became 10%. And also in another room, so this drop also quite a lot. So the other room was improved significantly. Let's go further. Then regarding survey results, so the survey result was carried out in 2019 with a response rate of 61%, but in 2020 the response rate was much higher, 83%. So when we compare this blue that was in 2019 and this red one was in 2020, so it shows that the perceived indoor environment was improved. Well, comparing with 2019 regarding health symptoms, and we found out that in 2020, so a couple of symptoms were also significantly reduced, like a tiredness and also concentration problem. But as for some other symptom, it's reported more, like irritation and stuff or running nose. And then measurement results in the Salzburg school. So we see that the percentage of time outside recommended boundary values. So it seems that without taking any measures, so it seems the condition somehow, the condition got worse. So the percentage of time outside the temperature 22 Celsius degree increase dramatically in 2020. This may be due to some other issues we haven't investigated, and the increased temperature and also results in a very low relative humidity. So the percentage of time of relative humidity outside the recommended the boundary value 20% increase also dramatically. And then regarding the survey results, so we have this 2019, 2020. So since we haven't implemented any measures, so this perceived indoor environment somehow, very similar between those 2 years. And as for this health symptoms, and there are some like change, but not much. Then remarks. So measurement and analysis carried out by an independent party are good tool for school management and municipality to uncover challenges and implement the right measures. And the combination of both measurement interviews and surveys provide good conditions for assessments, assessing the indoor climates, the schools. Cross evaluation of the results is important. Information and awareness raising are important for building a common culture and being able to implement routines that can contribute to school on hold, having a satisfactory indoor environment during the waiting period. And the last study is about machine learning tools and the indoor environment in schools. So as we have learned that the indoor perceived indoor environment and the health symptoms are very complex, and there are many factors that may contribute to health symptoms, and even in one classroom, and students may experience different indoor environment. And then we tried different machine learning models for prediction of indoor air quality and also for prediction of the effect of indoor environmental parameters on health. So for prediction of indoor air quality, we tested random forest model and Adam both. And as for prediction of the effect of indoor environment parameter on health, we tested XGBoost and CatBoost. And here are machine learning results in 2 schools in Oslo. So this this study was carried out in Brand-Fair school. So this is a middle school, which is it's located in Oslo municipality. So this figure shows the 5 most important features for the first 6 health problems at Brand-Fair school. So we found out that for fatigue, and there are 5 most important features, which means that dust and the dirt, and the second is heat from the ovens, and the third one is unpleasant light, and also this noise and too hot. And then as for headache, feeling heavy-headed and dizziness, and this too hot plays the number 1 factor. Then as for last 6 health problems at Brand-Fair school, like irritated nose and rawness and coughing. So these are caused by different other parameters. For example, even gender is a number 1 factor for irritated nose, at least from the data we collected. So it's a very interesting results. So the machine learning result in Price-Dawson school shows quite different analysis angle. So like a fatigue, so this heat from the sun, and even this asthma contribute to this fatigue in that school, and also the grade and per IQ, these are, and also this unpleasant smell. So these are the 5 most important features for fatigue. But for headache, so we can see that unpleasant this light and this per IQ. So these are the first the most important 2 most important feature for headache. But feeling heavy-headed, so this heat from sun play important role. But as for the last 6 health problems, so I think this is the same. Okay, but then we skip the school results. Then we compare the most important feature for different data. So we have 3 columns. So this column shows our earlier study by using survey results from many different schools, and then compare with the machine learning results in separated schools. So we see there are big differences. So as for this raw data, it shows that per indoor air quality contribute to, or per indoor air quality is the number 1 most important feature for the most of those health symptoms, like a headache. Per IQ contribute to a headache and contribute to feeling heavy-headed and contribute to dizziness and contribute to concentration problem and itching and irritated. So these and also this itching symptom. So this per indoor air quality is a number 1 E factor. But in sorry. It could be, but in Brand-Fair school, so it seems like this too hot contribute to many health symptoms like headache, feeling heavy-headed, dizziness, and also this dry and irritated skin and itching. But in this Price-Dawson school, it seems like various factors may contribute to different health problems. Then remarks. So the most important 3 features for whether the pupil experienced different health problems are per indoor air quality, too hot and dry air, which may have negative effect on pupils' health in Norwegian schools. All the schools have classrooms with temperature above 22 Celsius degree, which result low relative humidity. This should be avoided to reduce negative health effect and learning performance of students. Well, as Kat recommended, that I prepared these 3 key take-home messages from our earlier studies. The first one is a combination of both measurements, interview, and surveys provides good conditions for assessing the indoor climate at schools. And the pupils at schools which were controlled by advanced heating, ventilation, and air conditioning system may be satisfied more with the indoor climate. And machine learning can be used to recognize relationships between different indoor environment experience and health problem. 3 most important features per indoor air quality: too hot and dry air were recognized in Norwegian schools, where negative effect on pupils' health have been reported. And here's a list of the reference. Thank you for your attention.
Excellent. Thank you, Guangyu. That was a very nice talk. So let me just check. I can't see any hands at the moment, but if anyone has any questions, they can either, hold on, there's some stuff in the chat which I hadn't seen. No, that's just from Kat. I'll come to that later. So if anyone has any questions, feel free to either write in the chat or just raise your hand or simply unmute and ask your questions. I mean, in the meantime, do have a couple of questions. Which machine learning techniques did you use, and what data did you use to train those algorithms?
Well, I mentioned that a few these machine learning models we use and tested random forest. So this model can be used for classification and regression. And we also tested also other both. And so these 2 are used for indoor air quality prediction. And then as for this prediction of the effects of indoor environment parameter on health, and we tested this XG boost and the CAT boost. So in fact, CAT boost the machine learning algorithm that use gradient boosting on decision trees. So these for these models we use measured well, for the prediction of indoor air quality. So we use several measured indoor parameters like temperature, relative humidity, and CO2 particulate matters, and sometimes we even may include the outdoor environment. And then as for prediction of the effect of perceived indoor environment on health, then we we use all the response from users as input, exclude the one we are investigating. For example, headache or fatigue. So then we put all other perceived air quality as input to train the model, because there's when a student answer those questions, in total we have 38 questions, and there are 2 categories of questions. One is perceived indoor environment quality, and the second category is health symptoms. And we assume those perceived indoor environment quality will determine the health symptoms, right? So then we use all these perceived indoor environment as input, and as use health symptom as output, and try to build the correlation. So for example, the model we use this I mentioned the last slide of machine learning. It's raw data. We use over 4,000 data to train the model.
Excellent, thank you. And I guess one of the messages that came across to me, at least, was that there was a reasonable degree of variation between the three schools, and I wondered, sort of, perhaps thinking, from a perspective of the Norwegian government, to what extent do you think the variation you saw represents the variation across Norwegian schools? And, if are there any sort of key messages that you would give to either the Norwegian government or those building schools in Norway, based on your sort of research?
Yeah, that's very good question, Harry. So in fact, during the weekend and together with other colleagues, we somehow exchange ideas to provide feedback to the government, because the Norwegian government now is updating the suggestions for school indoor environment. And the current version regarding the air quality, it includes the recommended temperature, relative humidity, and CO2 level. But in fact, the CO2 level cannot be considered as the indoor air quality. Well, instead, CO2, in fact, may be used to estimate the ventilation rate related to occupants. Because in indoor environment, human being will produce CO2, right? But we cannot say that a room with a low occupancy, with a low CO2 level, will have a better indoor air quality, right? Because there are, if we have just less occupants, then we produce less CO2. But if ventilation is not sufficient, and then the concentration for other type of pollutant may be higher. So we recommended that this new guideline should present the minimum ventilation rate, because in Norway we have a building regulation. It's called TAC 17. So in TAC 17, it stated that the minimum airflow rate for public building. So we, in fact, we already somehow agree that this minimum airflow rate should be presented in the Norwegian guidelines. Yeah, I don't know what kind of this guideline in UK, because before my presentation we shortly discussed that in UK most of schools use natural ventilation, but
Yeah.
how this challenge may be tackled.
Yeah, I mean, well, in the UK, the guidance does specify values of daily average CO2 during occupied hours that should be kept below. But it does also mention, many of the key indoor pollutants that might be associated with schools. But I think that guidance, dates back now to 2018. So I think it will probably be revised in the next few years, and it'll be interesting to see which direction things are taken. In this very context, actually, Guangyu, there's a question in the chat from Patricia Fabian, who I happen to know does a lot of work on the Boston public schools. Patricia, do you want to ask your question?
Sure. Thank you for your talk. Super interesting. I was curious about the poor indoor air quality definition, kind of thinking towards solutions. Schools don't have very good standards, right? And they certainly don't have a mix of standards to follow. So the question was sort of what went into the poor air quality definition, and if it was measurement or perceived. But then the follow-up to that is sort of thinking about, could you tweak your measurements, do the machine learning to a point where you could find the right combination of parameters that resulted in no symptoms to inform things like standards. But maybe the first piece.
Yeah, thank you, Patricia. This is a very good question. Well, in fact, in our machine learning or in the investigation, as I mentioned already, that the measurement result does not always agree with the perceived indoor environment. So that means that we, as a human being, we perceive the environment in somehow different way comparing with our measurements. And then in our investigation, we also use a simple question like how do you feel the indoor air? Or it's a bad or worse, but it's a bad or good. So in fact, that we our experience tells us that the more options we provided and the less chance we may get feedback. So we for this question, I just asked that how we define per air IAQ. So students have only two options if they think the if IAQ is poor or not. So then for our machine learning, we got 1 and 0. In fact, for our questions, we only have two options. Whether, well, they do have a third option, they don't know. But then in machine learning, we leave it empty. So we use some other algorithm to deal with this missing data, missing data phenomena. But when we have enough data, so with 1 and 2, we can already represent this per IQ issue. But definitely you are right. So it's not always to clarify the scale of per IQ. So even we can use this PD, predicted percentage of dissatisfaction due to poor indoor air quality. We can use a -1 to +1, and the student can provide this mean vote. Then we have like a detailed scale of this per IQ. But for school kids and after some practice, we still found that less option for students to answer and the better chance we get feedback.
Yes, yeah, surveys are always a balancing act of simple enough that you might get a good response rate and detailed enough that you can make some research finding space in it. Well, that brings us, I think, to the end of today's talk. Just to note that the next talk will be a week today, same time, same place. Professor Dong Chung-shin will talk about the Korean National IAQ project. So, and that's being led by the School Particulate Matter Center for Energy and Environment Harmonization. So it's a nice reflection of this international seminar series that Guangyu has been part of today. And a reminder that if you want to join the TAPAS mailing list and get the monthly newsletter, just visit the website. Kat put that in the chat at 13:39 in my time. So dig that out, or email Kat directly if you need. Oh, and very final point before I say goodbye is just to say that Guangyu's talk has been recorded, as I'm sure Zoom made you all aware as you joined, and it will be uploaded to the internet, which you can then find on the TAPAS network. So finally, thanks again, Guangyu. A really, really interesting talk. Nicely varied in terms of measurements and surveys, and then Patricia's question, really highlights the challenges and technologies that we might use to sort of tie these difficult things about balancing measurements versus perception together in the future. So thank you very much for that. So hopefully we'll see you all here next week, and in the meantime, have a good week. Bye-bye.
Thank you, Henry and Kat. Thank you, everyone. Bye-bye.
Bye-bye. Thank you.
Thank you. Bye.
Bye.